Imagine walking through a dense jungle. The air is thick, humid, almost suffocating. The trees around you are massive, ancient, and alien. The ground beneath your feet is soft, waterlogged, and then you hear it, a slow, rhythmic movement in the water nearby, a ripple, then another, and then a shadow. Something enormous, something that shouldn't exist. This wasn't a monster from a movie, this was real, and it lived right here on Earth, 60 million years ago. Meet Titanoboa cerehonensis, the largest snake that has ever slithered across this planet. The story of Titanoboa doesn't start in a jungle. It starts in a coal mine in northern Colombia, the Cerrejón mine, one of the largest open-pit coal mines in the world. In 2009, paleontologists sifting through ancient rock layers made a discovery that stopped them cold. Vertebrae, massive vertebrae, bigger than any snake vertebrae anyone had ever seen. At first, scientists weren't even sure what they were looking at. The bones were so large that initial estimates thought they might belong to a crocodile. But the shape was unmistakable. These were snake vertebrae, and they were huge. The species was named Titanoboa cerehonensis, Titanoboa after its titanic size, cerehonensis after the mine where it was found. What followed was one of the most exciting paleontological discoveries of the 21st century. Because the more scientists studied these bones, the more they realized this creature had rewritten the rulebook on what a snake could be. Let's talk size, because this is where things get genuinely hard to wrap your head around. The average green anaconda, the largest snake alive today, reaches about 17 to 20 feet in length and weighs up to 250 pounds. Impressive, right? Now forget everything you know about anacondas, because Titanoboa was estimated to be around 42 to 47 feet long. Some estimates push it even higher, up to 50 feet. That's longer than a school bus. That's longer than a double-decker bus. That's a snake so long that if it coiled around your living room, it would fill it completely. And the weight? Scientists estimate Titanoboa tipped the scales at over 2,500 pounds. That's over a ton. That's heavier than a car. A snake, heavier than a car. At its widest point, the body of Titanoboa was roughly the width of a grown man's hips. If you were standing next to one, you wouldn't even reach its back. And its head? Large enough to swallow animals that would seem completely absurd to us today, whole. This wasn't just a big snake, this was a megafauna apex predator in a league entirely its own. Here's where Titanoboa gets scientifically fascinating, because its size wasn't an accident. It was a direct result of the world it lived in. Titanoboa lived during the Paleocene epoch, roughly 58 to 60 million years ago, shortly after the extinction of the dinosaurs. And the Earth back then was very, very different from today. Global temperatures were dramatically higher. The tropics, where Colombia sits, were even hotter and more humid than they are now. Mean annual temperatures in that region are estimated to have been around 30 to 34 degrees Celsius. That's significantly warmer than today's Amazon. And here's the key. Snakes are ectotherms, cold-blooded. Their body temperature, and therefore their metabolism, their growth, their entire biological function, is governed by the heat of their environment. The hotter the environment, the larger a cold-blooded animal can grow. It's a relationship called Bergmann's rule in reverse. In tropical heat, reptiles can reach sizes impossible in cooler climates. Scientists actually used the size of Titanoboa's vertebrae to reverse engineer the temperature of the ancient tropics. The snake became a thermometer for the past, and what it told us was startling. The ancient tropics were far hotter than many climate models had predicted. Titanoboa didn't just tell us about snakes, it told us about the history of our planet's climate. Think about that. A fossil snake, helping us understand global warming millions of years before humans existed. Now let's get to what everyone really wants to know. How did something this big hunt? What did it eat? And how did it kill? Titanoboa was almost certainly a constrictor, like modern boas and anacondas. It didn't have venom. It didn't need it. When you're over 2,500 pounds of pure muscle, you don't need poison. You just squeeze. The ancient Cerrejón ecosystem was rich with prey. Giant turtles roamed the area, some with shells over 5 feet wide. Massive crocodilians lurked in the same waterways, and Titanoboa ate them, not as a last resort, as a regular meal. Fossils found at the same site show large Titanoboa remains alongside giant turtle and crocodilian bones, suggesting these weren't rare encounters. This was the food chain. Paleontologists believe Titanoboa was primarily aquatic, or at least semi-aquatic, spending much of its time in rivers and swamps, much like today's anaconda. It would have been an ambush predator, lying motionless in the water, using its massive bulk to explode forward and coil around prey before the victim even knew what had happened. The constricting force of Titanoboa would have been unlike anything alive today. Modern anacondas can exert around 90 pounds of pressure per square inch. Scale that up proportionally for Titanoboa's size, and you're looking at crushing force that would have been simply unsurvivable for virtually any animal alive at the time. There was no escape, not from something that size. To truly understand Titanoboa, you have to understand the world it ruled. The Cerrejón ecosystem of 60 million years ago was unlike anything on Earth today. This was a post-dinosaur world, but life had already exploded back in extraordinary ways. The forests were dense and ancient. Rivers wound through vast tropical lowlands, and the animals that filled these niches were bizarre by modern standards. Alongside Titanoboa lived Carbonemys, a turtle so large it's been nicknamed coal turtle, with a shell roughly the size of a smart car. There were giant lungfish, early relatives of modern crocodilians that were themselves massive animals, plants that had no modern equivalent. Titanoboa sat at the absolute top of this ecosystem. Not just a predator, the predator. Nothing hunted it, nothing challenged it. In a world still recovering from the asteroid impact that wiped out the non-avian dinosaurs, Titanoboa filled the ecological role of the apex megapredator with ruthless efficiency. For millions of years, this snake was the undisputed ruler of the most biodiverse region on the planet, and it never had to worry about competition, because nothing could compete. So if Titanoboa was this dominant, this perfectly adapted, why did it vanish? The answer, like everything about this creature, connects back to climate. Around 58 million years ago, global temperatures began to shift. The extreme heat of the early Paleocene slowly began to moderate. The tropics cooled, not dramatically by human standards, but enough. And for Titanoboa, even a few degrees of average temperature drop would have been catastrophic. Remember, Titanoboa's enormous size was dependent on heat, its metabolism, its growth, its ability to process the massive amounts of food it needed. All of it was tied to a warm environment. As temperatures fell, maintaining a body of that size became increasingly difficult. Smaller snakes, more adaptable, less metabolically demanding, outcompeted the giants. The ecosystem changed too. The ancient forests of Cerrejón transformed. Prey populations shifted. The perfect conditions that had allowed Titanoboa to reach its extraordinary size simply stopped existing. And so Titanoboa disappeared. Not from a catastrophic event, not from a meteor or a volcano, but from a slow, steady, almost invisible shift in the planet's temperature. A few degrees. That's all it took to erase the largest snake that ever lived. There's something almost haunting about that. A creature that ruled its world absolutely, brought low not by a predator or a disaster, but by the weather. Titanoboa lived 60 million years ago. It went extinct long before the first humans walked the earth. And yet, in so many ways, it speaks directly to us. It tells us about the deep connection between life and climate, how even the most dominant creature on the planet is ultimately at the mercy of temperature. It tells us about the incredible capacity of life to fill every possible niche, to grow to unimaginable sizes when conditions allow. And it tells us that the world we live in now, temperate, familiar, relatively stable, is not the only world Earth has known. Nothing about Titanoboa was normal. But maybe that's exactly what makes it one of the most extraordinary animals that has ever lived.